Hi there, my name is Jeremy Krug, and in this video we'll be practicing and walking through 15 different multiple choice questions, styled just like you'll see on the AP Chemistry exam. If you're new to my channel, welcome. Take a look around. I think you'll like what you see here. Check out the playlists, that's where the action is. If you find this video helpful to you, please hit that like button. And if you plan on coming back to learn and review more chemistry, hitting that subscribe button will make sure you don't miss a thing. This is a relatively small channel, so your likes and comments really do make a difference. Thank you for watching. Now, to really get the most out of this video, I recommend that you print out the PDF of the questions linked in the description down below. Give yourself about 22 minutes to answer these questions. That's about a minute and a half per question, just like you'll get on the AP exam. Then, when you're done, watch the full video and see how you did. And if you want more multiple choice practice and walkthroughs, remember that my ultimate review packet for AP Chemistry has a lot more of these. 2 full practice AP exams with full walkthroughs for every multiple choice question, not to mention unit summaries, study guides, even more practice questions. And if you're already a subscriber to the Ultimate Review Packet or the Ultimate Exam Slayer, you'll find today's questions under Exam Review Resources in the AP Exam Simulator. So you can practice these questions in a format that looks just like the College Board's online exam platform. Now, let's get started. Question 1 is about patterns and properties on the periodic table. It says, which of the following provides the best explanation for the difference between the atomic radii of calcium and selenium? Well, whenever we're comparing the radii of 2 atoms on the periodic table, there are a couple factors that we need to take into account. Now, you might remember this graphic from the YouTube videos or from the Unit 1 summary video on the Ultimate Review Packet. And whenever we're comparing these 2 atoms, calcium and selenium, we notice that they are across from each other on the periodic table. They're in the same row, the same period, but we know that the one that's farther to the right has more protons. It has a greater effective nuclear charge. And so in this case, we can say that selenium has more protons. Calcium has fewer protons than selenium. And that's the reason why the atomic radius of calcium is larger. It's important to remember that the atoms that are on the left side of the periodic table are larger than the atoms on the right side of the periodic table. And so this graphic hopefully will help us to see that. And so that's why the answer is choice B for question number 1. Question 2 says a metal X reacts with bromine to form the compound XBr. Which of the following could be the ground state electron configuration for X? Well, if we think about that compound that has the formula XBr, we know by looking at the periodic table that the bromide ion has a -1 charge. And so if bromide is -1, then the X cation would have to be +1 in order for that ionic compound to be neutral. Now, if we think of cations that have a +1 charge, well, that sure sounds like these ions here, or these elements in the first column or the first group of the periodic table. And we know by looking at our patterns of electron configurations that those ground state configurations are going to end with S1. It might be 2s1 or 3s1 or 4s1 or something like that, but it's going to be S1 at the end of its electron configuration if it is an alkali metal. And so the only one that fits that would be choice D. And so that's why the answer to number 2 is choice D. 1s2, 2s2, 2p6, 3s2, 3p6, 4s1. And that would be the electron configuration for potassium, and that certainly does make sense for this question. Question 3 asks us about this particle diagram here. It says the particle diagram pictured here represents a mixture that results after samples of hydrogen gas and oxygen gas have been mixed and ignited with a spark, producing water vapor. Which of the following statements correctly identifies the limiting reactant and provides an appropriate justification? So once again, we have 2 reactants in this reaction. We have hydrogen, H2, and O2, oxygen. And we know that the limiting reactant is the reactant in a reaction that's completely consumed. That means at the end of the reaction, there should not be any of it left over. Well, as I look at the diagram here, I notice that there are a couple of molecules of O2 that are still left in the mix, but there is no more H2. The H2, well, I just can't see any molecules of H2 here. So that tells me that H2 is the limiting reactant. And the reason is, as we see in choice A, because there is no unreacted hydrogen gas present in the mixture. It doesn't really have anything to do with the molar mass. It's just how much is left over. And in this case, since there is no hydrogen left over, that means hydrogen is the limiting reactant. Question 4, we have a laboratory investigation. It says several 1 gram pieces of magnesium metal are dropped into excess hydrochloric acid and are allowed to react according to the reaction we see here. 4 separate trials are carried out. In the trials, the temperature and concentration of the acid are varied, as shown in this table. Which of these 4 trials most likely had the slowest reaction rate? Well, as we learned in Unit 5 over kinetics, the faster the reaction rate, it's normally going to have a higher temperature and a higher concentration of the reactants. Well, in this case, the question is asking about the slower reaction rate. Well, that implies that we're going to have a lower concentration and a lower temperature of the reactant. So all we have to do is look at that chart there and find the trial that has the lowest concentration and the lowest temperature. And to me, that seems to be trial 3, which is right here, 0.75 molar and 15 degrees Celsius. So that's why the answer is choice C for this question. Question 5, we have a chemical reaction. It says the decomposition of hydrogen peroxide into water and oxygen gas is represented by the equation above. The reaction is first order with respect to hydrogen peroxide. If all other conditions are held constant, what initial concentration of hydrogen peroxide will result in an initial formation of oxygen gas that is 4 times higher than the rate in trial 1, as shown in the table? So if we look at the table here, we can see that from trial 1 to trial 2, the rate of the formation of oxygen is going up by a factor of 4. Now, if this reactant is first order, H2O2 is first order here, that means that if we have a rate that's quadrupling, whatever the concentration is doing, it's going to be affected by a power of 1 because it's first order. And so basically we just have to answer this question. What to the first power equals 4? And I think we all know that that is 4. So that means that the concentration must be increasing by a factor of 4. And since that's the case, 0.15 molar times 4 is equal to 0.60 molar. And so that's why the answer is choice C for question number 5. Question 6 is about lattice energy and Coulombic attractions between charged particles. It says lattice energy is the delta H associated with the separation of a solid ionic crystal into gaseous ions. The chart lists the lattice energy for 3 common ionic compounds. Based on the data shown and the properties of the compounds, what can we conclude about the lattice energy of magnesium bromide, MgBr2? Well, the first thing we have to realize is that lattice energy has everything to do with Coulombic attractions between the charged particles. We need to realize that lattice energy increases as the magnitude of charge increases. And this is because Coulombic attractions between the particles are stronger when we have a higher magnitude of charge. So if we look at the magnitude of charge for all 4 of these compounds, we can see that KBr and NABr are both compounds that have a +1 -1 ion pairing in there. And that explains why those 2 compounds have the lowest lattice energy on this chart so far. Well, CaBr2 and MgBr2 are both going to be +2 -1 ion pairs. So that tells us that they're both going to have lattice energies that are higher than those other 2. So we know that magnesium bromide is going to have to be greater than 736. But what if we have a tie like we have here? We have 2 compounds that are both +1 -1. Well, if there's a tie, it's broken by the ionic radius, because we know that lattice energy increases as ionic radius decreases. And once again, this is because as charged particles get closer to each other, their Coulombic attractions tend to increase. And so if we look at the periodic table, we can see that magnesium is going to have a much smaller ionic radius than calcium. And so that tells us that since the magnesium and bromide ions are closer to each other than calcium and bromide ions are, we're going to have a higher lattice energy for magnesium bromide than we even had for calcium bromide. So the answer is choice D. The lattice energy of magnesium bromide is greater than 2,034 kilojoules per mole. And that's because we have a higher magnitude of charge and the distance between magnesium and bromide is smaller than the ionic distance between calcium and bromide. Moving on to question 7, we have a Maxwell-Boltzmann distribution here, and we have 3 curves. It says the 3 curves represented in the graph shown here represent the distribution of the molecular speeds for the 3 gases fluorine, neon, and chlorine at 40 degrees Celsius. Select the curve that corresponds to each gas. Well, one thing we need to know about the speed of molecules is that if we're at the same temperature, the less massive molecules are going to move more quickly. They're going to have faster average speeds. And so to find the masses of these molecules, we just have to consult the periodic table, and we find that fluorine, F2, is about 38 atomic mass units, neon is about 20, and chlorine, Cl2, is about 71 atomic mass units. Now, we know by looking at this chart here, at this graph, that A, whatever A is, it has the lowest average molecular speed. And guess what? The one that has the lowest average molecular speed is the one that's the most massive. So that would have to be chlorine in this case. So chlorine is the slowest. That's curve A. And then the lightest molecule would have to be curve C. So that seems to be neon. So we know that neon is the fastest. That means that fluorine is going to have to be curve B, which is kind of in the middle there. And so that's why the answer is choice C for this question. Curve A is chlorine, curve B is fluorine, and curve C is neon. Moving on to question 8, it says, which of the following gases most closely approximates the properties of an ideal gas at 25 degrees Celsius and 1 atmosphere? Well, when we talk about gases that most closely approximate ideal conditions, we know that gases tend to most closely approximate ideal conditions at higher temperatures and lower pressures. Well, it says all 4 of these gases are at the same temperature and pressure, so that's not going to help us here. So in the case where they have the same temperature and pressure, the gases that most closely approximate ideal conditions are gases that have the weakest intermolecular forces and gases that are just tinier, gases that are smaller in size. Well, if we think about the intermolecular forces among these 4 gases here, if you were to draw the Lewis diagrams for all 4 of these, you'd find that SF4, sulfur tetrafluoride, and NF3, nitrogen trifluoride, are all polar molecules. And so since they're polar molecules, they're going to tend to have stronger intermolecular forces than nonpolar molecules. Since they're polar molecules, as we've learned, they're going to have those dipole-dipole forces. And so that's why we can eliminate choices A and C. So as we narrow it down to choices B and D, we have to think to ourselves, which of those 2 molecules is a tinier molecule? Which of those has weaker intermolecular forces? Well, we know it's choice D because that CH4 molecule is, first of all, less polarizable since it has fewer electrons, so its intermolecular forces are weaker, and CH4 is just a smaller molecule than C3H8. And so that's why the answer is choice D for this question. Moving on to question 9, it says a student weighs a sample of a group 1 metal, R, and carefully adds it to a carefully weighed sample of excess water to react as shown in the equation here. The student measures the initial temperature of the water both before and after the reaction. The student uses the specific heat capacity of a dilute aqueous solution to calculate the number of joules released. Which of the following questions is most likely to be answered as a result of this investigation? And we have 4 choices. What is the density of the metal? What is the value of delta H of the reaction? what is the value of the specific heat capacity of metal R, and what is the melting point of metal R? Well, the first thing that jumps out at me here is that we're not ever actually melting the metal, are we? We're reacting the metal. And so since we're not melting anything, choice D can automatically be taken out. We're not determining the melting point here, so that is irrelevant. And something else that jumps out at me here is that in order to measure the specific heat capacity of a metal or of a substance, that metal has to remain intact. And it's not in this case. Since R is reacting, we can't really determine the value of the specific heat capacity of the metal in this way. So that means choice C can also be eliminated. Now, choice A asks about the density. Well, we know that to calculate the density of a material, we have to take the mass divided by its volume. Now, even though we did find the mass of the metal, the problem never said that we actually found the volume of the metal. So we can't really determine the density of the metal either. So choice A can be eliminated also. So that's why the answer is choice B. And if we look at the information that we have here, the value of delta H would be fairly simple to calculate using the information that we have in the question. Moving on to question 10, we have a delta H question, and it says, which of the following explanations best explains why the enthalpy change of the reaction shown here is negative? And we have 4 choices. Now, one thing that jumps out at me here is that if the value of delta H is negative, that means the reaction is exothermic. And we have 2 choices, choice A and B, that don't even say that. It's trying to claim that the reaction is endothermic. So I can eliminate choices A and B just right here at the beginning. Now we also notice that if we look at the equation here, it looks like we're forming a bond between these 2 atoms. We have Br and Br atoms, and we're forming a chemical bond. Now we should know that whenever you form a chemical bond, that releases energy. Forming chemical bonds release heat energy. Now, we know that breaking chemical bonds absorb heat energy. And so that's why the answer here is choice D. The reaction is exothermic because forming a bromine-bromine bond releases energy. Moving on to question 11, we have an acid-base problem. It says a 0.050 mole sample of solid KOH is added to a 150 milliliter sample of 0.50 molar HCl. Assuming the volume of the solution does not change, the pH of the resulting solution is closest to which of the following? Well, we need to be able to recognize that in this reaction, we're adding a strong acid to a strong base. And anytime we have a strong acid, strong base reaction, the net ionic equation is equal. It's H plus OH minus yields water. Now let's figure out how many moles of each of these reactants we have. Now the problem comes out and tells us that the moles of KOH will be equal to 0.05 moles. However, the moles of H plus will be equal to the concentration times the volume in liters. So 0.50 molar times 0.15 liters. And when we multiply that, we find that the number of moles of H plus is equal to 0.075 moles. So let's take these 2 mole values and set them up into a stoichiometry icebox here. So H plus, we have 0.075 moles, and hydroxide we have 0.05 moles. And we see that hydroxide is the limiting reactant here, so we can subtract 0.050 moles from both values, and we find that the hydroxide is completely gone since it's the limiting reactant, and H plus as the excess reactant will be 0.025 moles. Now, in order to find the pH, we have to have not just the moles of H plus, but the molarity. And so molarity of H plus will be equal to the 0.025 moles divided by the volume of the solution. It says in the problem that the volume of the solution does not change. So that means that we still have 150 milliliters or 0.15 liters of solution. When we divide this out, we find that the concentration of H plus is about 0.17 molar. So now to find the pH, all we have to do is take negative log of 0.17, and we find that the pH is very close to 0.78. So that's why the answer is choice A for this question. Question 12, we have an equilibrium question. This looks like Le Chatelier's principle, and it says the reversible reaction shown here takes place at 25 degrees Celsius. The reaction represented by this equation is at equilibrium at 25 degrees Celsius in a container with a movable piston. Which of the following changes would cause a decrease in the amount of the product carbon monoxide, CO, in the container? Well, let's just take a look at these one by one. The first one says decreasing the temperature. Well, first we can look at the delta H for this reaction, and we see that since it's a positive value, the reaction is endothermic. Now, in endothermic processes, heat is acting as a reactant. So if we write in heat as a reactant here, and we're decreasing the temperature, that means we're essentially removing heat. So if you remove heat, or any reactant for that matter, we know that the reaction is going to shift toward the reactant side. That means we're going to have more reactants at the expense of the products. So that means that the carbon monoxide concentration is going to decrease. And so yes, the answer seems to be choice A. But let's go on through these other choices here just to make sure. Now, choice B says raising the piston causing a decrease in pressure. Whenever you raise the piston in a system like this, we're essentially increasing the volume. And we know that when you increase the volume, decrease the pressure, equilibrium is going to shift toward the side with more moles of gas. On the reactant side, we have 1 mole of gas. On the product side, we have 2 moles of gas. So that means that increasing the volume, decreasing the pressure, is going to cause more carbon monoxide to be formed. So that's why B is not the answer. Now, choice C says adding carbon dioxide gas to the container. Well, we know that anytime we add a substance to a mixture at equilibrium, it's going to cause the reaction to shift toward the other side. So in this case, when we add carbon dioxide, it's going to try to deplete that, and so it's going to cause an increase in the amount of carbon monoxide as well. And so that's why the answer is not choice C. Well, how about choice D? What about removing carbon solid from the container? Well, the fact is, solids do not have any effect on equilibrium. So we can remove the solid carbon, and it's not really going to have any effect on equilibrium. So that's why the answer is choice A for question 12. Question 13 is a question about thermodynamics from Unit 9. It says, consider the equation shown here that takes place at 25 degrees Celsius. Which of the following statements about the thermodynamic favorability of this reaction at 25 degrees Celsius is true? Now, the first thing I notice is that the delta H for this reaction is positive. That means that this is an endothermic process. And we know that the universe doesn't really like endothermic reactions that much. The fact that this is an endothermic reaction does not contribute to its thermodynamic favorability. So that means we can automatically eliminate choices A and C, because both of those choices imply that delta H is contributing to thermodynamic favorability, and, well, it's not. So I'm going to mark out A and C. Now, one other thing I notice here is that entropy is increasing in this reaction. Now, let's see how we find that. We notice that we start out with a solid, and then it transitions to liquid and gas. And so solid has the lowest entropy. Liquids and gases have much higher entropy. So we can say that entropy is absolutely increasing in this reaction. Now, the universe likes that. The universe likes when reactions have increasing entropy. And so that does contribute to the thermodynamic favorability of this process. And so that's why the answer is choice B. Only the delta S, the entropy change of the reaction, contributes to this reaction being thermodynamically favorable. So that is the answer to number 13. Moving on to question 14, we have a particle diagram. It says, in the particle diagram shown here, metal B reacts with the gas A2. Which of the following is the most accurate statement regarding what happens to element A in the course of the reaction? And we have answer choices that all talk about reduction and oxidation. So let's think about what happens when we have substances that are being oxidized and reduced. One thing we have to realize is that both of these reactants are pure elements. And all elements in their most natural state have an oxidation state of 0. We know that when they react with each other, metals tend to be oxidized, nonmetals tend to be reduced. And if you're not sure where we get that from, think about the overall balanced equation. We can write an equation for this. We can say that the B plus A2 yields B2A3, And then we can balance this, and we can see that the A, which is the nonmetal, is being reduced. Now, since A is being reduced, we can automatically eliminate choices C and D because element A is absolutely not being oxidized here. Now, since element A is being reduced, what's actually happening to it? Well, think about that little mnemonic aid oil rig that you may have heard before. Oxidation is losing, reduction is gaining. So that means that A is gaining electrons since it's being reduced. So it's gaining. It's not losing or donating electrons. That's why the answer is choice B. The element A is reduced because its oxidation number decreases. It starts at 0 and then ends at some negative value as it becomes an anion. Moving on to question 15, our last one here today. Pictured here is the titration curve for an acid-base reaction carried out in the laboratory. Which of the following molecular equations could represent the reaction used in this titration used to produce the graph? Well, one thing I notice by looking at the titration curve here is that the titration seems to be between a strong base and a weak acid. I know that for a couple of reasons. First of all, the equivalence point is above 7. Since the equivalence point is above 7, that means it's a strong base and a weak acid. I also notice that the pH starts out at a moderately low value, about 3. If this were a strong acid involved here, we'd start out with a pH much closer to 0. Well, since it's a strong base, weak acid titration, I can automatically eliminate choices A and B because choice A is a strong acid, weak base titration, and choice B is a strong acid, strong base. And so A and B are automatically out. Now I'm left with choices C and D, and in both of those choices, we have a weak acid and a strong base. Well, one thing I notice here about choice D is that this choice has a diprotic acid. And a diprotic acid cannot be involved in this titration curve. And the reason for that is that the titration curve only has one inflection point. This only has one equivalence point. If there were a diprotic acid involved, like H2CO3, this titration curve would have 2 inflection points. And so since we don't have that, the answer has to be choice C. So yes, this very well could be nitrous acid being reacted with potassium hydroxide to make water and potassium nitrite. Hey, I hope that was helpful. If so, I would appreciate it if you slammed that thumbs up button. And if you like this video, then check out this video right here that will help you get even more review for the AP exam and meet your goal. So keep up the good work, and I'll see you soon.